Hello students. In the last class we are discussing regarding the mechanism of nucleophilic substitution reaction, that is SN1, SN2 mainly we discussed. But we know haloalkane mainly shows two types of reaction, that is nucleophilic substitution, another is elimination. The elimination of haloalkane already we have discussed, that formation of alkene and alkyne from haloalkane. But what are the mechanism, how the reaction takes place, what are the stereo selectivity and stereo specific stereochemistry of the reaction, let us discuss. Generally, elimination reaction if you see the mechanism, it is of three types. One is E1 reaction, second one is E2 reaction, third one is E1CV reaction. But first one, second one is very important. Let us discuss all three. So E1 reaction, E2 reaction and E1CV reaction. If you see the elimination reaction, here what happens? The elimination generally takes place from two adjacent carbon atom. Two groups will be removed. With the loss of the two groups from the adjacent carbon atom, formation of unsaturated compound is observed. Loss of two groups from the adjacent carbon. But we are discussing mainly the mechanism of haloalkane. So halogen will be removed from alpha carbon, and from beta carbon, that is next carbon, that is one hydrogen will be removed. Loss of hydrogen from beta carbon and loss of halogen from alpha carbon. That's why in all these three cases, this elimination is called that beta elimination. This is also called as beta elimination, because the hydrogen will be removed from beta carbon. That's why it is called beta. It is also called as alpha beta elimination also, because from alpha carbon one halogen will remove and from beta carbon one hydrogen remove. That is also called beta elimination or alpha beta elimination. So E1, E2, E1 CV mechanism, like your SN1, SN2 mechanism. In E1 mechanism, what happens? Suppose let us discuss E1 reaction. In E1 reaction, what happens? Here, it is also two-step process. It is also E1 means elimination unimolecular. That is elimination unimolecular reaction. That means first order. Or let us take one example. Here, the step, what are the step involved in E1 elimination? A two-step process. First step, let us example, we take this one, CH3, 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 then let it be Br. In presence of alcoholic KOH, your product is CH2, CH3, then CH3. If you see, formation of double bond in one carbon. Loss of what? One Br and what? SBr. That is product is KBr plus what? So formation of one double bond is produced due to elimination. This is called, you can say alpha. This is your beta. So from beta one hydrogen will remove, and from alpha halogen will be removed. So it is also called dehalogenation, dehydrohalogenation, loss of hydrogen, loss of halogen. From hydrogen from beta carbon and halogen from alpha carbon. So this E1 mechanism, if you see, it is two-step process. In the first step, what happens? This, like SN1, what happens? This group first loses Br minus, forming carbocation, and Br minus, like your SN1. And it is also slow step. It is a slow step process and reversible, we can say. And this carbocation, what happens? In the second step, this carbocation having hydrogen, then CH3 having carbocation. What happens? When one base, strong base will be taken, then this base, this hydrogen will be taken by the base, which minus will abstract proton from the beta carbon. From the beta carbon, the OH minus acts as a base now. It is not a nucleophile, it is called as base because it is abstracting proton from the beta carbon, and this bond become double bond. So formation of what? Double bond. So this is alkene is produced, that is isobutene, formation of alkene. So this is first step. So two steps, E1 elimination unimolecular two-step process, formation of carbocation, and second step is the first step, loss of proton by base. This is called base, this is not nucleophile. Why is called? What is the difference between base and nucleophile? The substance which abstract proton from the molecule, that is called what? Well, that is base attack the hydrogen. It takes hydrogen. But nucleophile attack the carbon. This is the difference. That's why it acts as a base. So base will abstract proton from the beta carbon and forming alkane. So it is a two-step process. Slow step is the first step slow, second step is fast. So what is the mechanism? That is that is kinetics. dx by dt is equal to K and the subtract, that CH3 whole 3 CBr, concentration of this one. It depends upon the concentration of substrate, not depends upon the concentration of base. Concentration of base may be less or more, but there is no effect of the kinetics of the reaction. Only kinetics depends upon the concentration of the substrate. If you take more amount of substrate, the reaction will be fast. But the concentration of base, the amount of base will not affect the kinetics of the reaction. That's why it is only depends upon the concentration of the substrate. That's why it is called unimolecular or fast order reaction. This is regarding the concentration of the base with the rate determined step. Okay. Then second, here what happens in second step? What happens in the second step? The E2 mechanism. If you see the E2 mechanism, in the E2 mechanism, what happens? In E2 mechanism, here it is one step process. It is one step process. It is one step process. What happens? Here that means here the base, one step attacking of proton by the base, at the same time releasing of leaving group. Here what happens, that loss of leaving group, formation of carbocation, then attacking the base. That is two-step process. But here one-step process, both. That means loss of proton and releasing of leaving group takes place in one step. For example, if you take CS2H, then CS2Br with base, suppose OH minus, what happens? The product is same. Product is your CS2 double bond CS2 plus your water and formation of alkene. But formation of alkene, if you see here, the one-step process. One-step process means what happens here? Base, if you take this base here, suppose this is your hydrogen, then CS2, then Br. What happens if you take base here, OH minus? H will be taken by OH minus. At the same time, double bond is formed and loss of bromine takes place. That's why there will be a transition state. What the transition state? That attacking of base to the hydrogen, then loss of bromine, Br minus. So this is called transition state. This is a transition state at this. Although like your SN2 reaction, it takes place in transition state. Here in E2 also it occurs in transition state. Then what happens? Alkene is formed. CS2 double bond CS2 plus your Br minus. Plus Br minus. Here you can write. So it is one step process, attacking and releasing of the group and with the formation of what? Double bond. But here one thing, that either E1 or E2, if you see E1 or E2, here what happens? The elimination always takes place, that is called trans elimination, always takes place. We prefer trans elimination. Always prefer trans elimination. Why trans elimination takes place? Because trans elimination prefer the attacking of base for the beta hydrogen and the loss of group takes place easily. Because if it is cis, if the attacking go to the cis side, same side, then it will be crowded. So that there will be repulsion between the group and the nucleophile, leaving group and nucleophile. So to avoid elimination, to avoid that steric hindrance, the base will attack the proton in antiposition, that is in transposition. For example, CS2, here H you can tell, suppose H here, then single bond, then Br here. So always transposition. So here OH minus attack to proton this side and loss of group other side. So you can, this is a transposition and formation of double bond alkene. But it has been observed that elimination reaction always, already we have read, elimination always obey Setzer rule. It obeys Setzer rule. Setzer rule means more stable alkene is the major product. Major product is the most stable alkene. I can know which alkene is the most stable product because you have to see that alkene must contain across double bond the number of alkyl substituents should be more. For example, if you take CH3, CHBr, then CH2, CH3. If you take same OH minus, the product may be, if you take first carbon, then it will be CH2 double bond CH, then CH2, then CH3. Plus, if you take hydrogen from here, the product will be CH3, CH, double bond, CH, then CH3. If you see the alkyl substitution, here after double bond, one alkyl group is here, but here how many alkyl groups? 1 and 2. If number of alkyl substitution will be more, that is more stable. It is the major product, more stable product, major product, and it is the minor product. Because it is more stable, because due to hyperconjugation. Here hyperconjugation will be 6, here hyperconjugation will be 2. So it is more stable. This is called Selzeff rule. So during elimination, we have to follow the Selzeff rule, that is more substituted alkene will be the major product, which is the more stable product. This is the very important concept of the elimination reaction, Selzeff rule. And in addition reaction, we follow the Markovnikov's rule. So this is regarding E1, E2 mechanism. E1, E2 mechanism, and another very important E1CB. E1CB, have you written this one? You complete. Let me erase this one. Third one mechanism is, that is E1 CB mechanism reaction. In E1 CB what happens? So the first step, if you take same thing, CH2 single bond CH2 Br in presence of OH minus. Here what happens? First step is the two-step process. First step is the here the product is same, CH2 double bond CH2 plus Br minus plus what? But in E1CB what happens? A conjugate base is formed in the first step. So in the first step what happens? CH2H single bond CH2Br first will lose, that the OH minus will take, what happens? One proton from the beta carbon. From beta carbon, OH minus will take abstract one proton, forming conjugate base. And this is your called slow step. This is your slow step. This is fast step, not slow. This is the fast step. This is formation, that is fast step. This is your fast step process. This is fast step. Then this conjugate base will lose, that this minus charge will form double bond, then loss of leaving group, minus Br minus. This is your slow. This is your fast, then production alkane. So, as the conjugate base is involved in the formation of alkane, so this is the rate determining step. Here rate determining step is which one? Conjugate base. That means the dx by dt here is equal to K, what? That conjugate base, CH2 minus CH2Br. We can convert the concentration of CH2Br in terms of your substrate, we can convert it. But this is the rate will depends upon the concentration of conjugate base. Okay? But in E2 mechanism, you can write, in E2 mechanism, the rate is equal to K in both the substrate concentration and base, both. This is your E2 mechanism, E2 mechanism kinetics, and this is E1CB kinetics. What is the main difference? In E1CB what happens? Conjugate base is involved in the rate determining step, but in E1 the substrate is involved, but E2 both substrate and the base is involved. So this is the difference between E1, CB, E2 and E1. Then what are the factors? Factors very important is that tertiary haloalkane greater than secondary, greater than primary, that this order for E1 mechanism. Then opposite for E2. Tertiary haloalkane will be faster for E1 mechanism like your SN1 mechanism. Then leaving group, same nature of leaving group, that Ri will be faster than RBr, faster than RCl, faster than Rf. Same for elimination reaction also, iodoalkane will be faster than bromoalkane. This is order of both E1 and E2 for both is same order. Then if you see concentration, that weak base and low concentration, weak base and low concentration will favor E1 mechanism. But strong base and high concentration will favor the E2 mechanism. It is very important. If for E2 mechanism, R is one step, strong base will favor. Strong base and high concentration, because concentration base is also depends upon the rate. So high concentration and strong base will affect E2 mechanism, and low concentration and weak base will affect E1 mechanism. This is very important. But factors affecting elimination reaction E1, E2 like this. Then always the product always favor major product. You can write like this: major product must be highly substituted. Must be highly substituted as per the Sturgeon rule. Major products should contain what? More substituted alkyl group. So, and if you see the stereochemistry about this, that E1 reaction, E1 is stereoselective, but not stereoselective, stereospecific. It is stereospecific but not stereoselective. Stereospecific. That is stereospecific but not stereoselective. But E2 is both, means stereospecific and stereoselective. So this is the important conditions and important factors for the elimination reaction, and we have to see in which example is elimination, which example is E1, which example is E2. We have to take care of this. E2 means that concentration. If another thing also you can take, that polar solvent affect more E1 mechanism, but non-polar affect E2 mechanism. If more polar solvent, then E1 will be affected. Then non-polar means E2 will affect. So that means strong base. If base is strong and the medium is non-polar, then E2 mechanism will be preferred. But if you take the different types of haloalkane, but tertiary, greater than secondary, greater than primary. But similarly also you can take benzyl, greater than allyl, greater than tertiary, greater than secondary, greater than primary. In this is the order of that reactivity of haloalkane. If the nature is benzyl, then E1 will be faster. then allied, then your tertiary, secondary, primary, like this. So these are the mechanism of what? Elimination reaction. You practice different examples, then you can have better knowledge regarding elimination reaction. Okay, thank you all.